Hey everybody, I'm Tom. I work for Disney Streaming. I run an organization called Quality Targeting and Experience, or QTE, which is in the media engineering group. And I know we've talked about this before, that QTE, at least internally we've talked about this, QTE is very similar to QT, and so we went ahead and, when our leader first brought this up, we actually went ahead and just embraced it whole hog. You can see we actually made the little oranges our mascot, so we're okay with it. We've learned to live with it. At QTE, our main focus is thinking about how to improve the playback quality for video streams in order to create the best possible viewing experience for our customers. So that involves a lot of different techniques and different technologies. So things like ABR and prefetching and downloading and controlling how the video itself is streamed down to the user. In fact, you may notice that I've already mentioned Q for quality and E for experience. And that is not at all what this talk today is about. It's actually about the targeting part and how QTE engages with targeting. So before I go any further, I have to make a little bit of a mea culpa. I work for a company that produces really iconic characters like Mickey Mouse and Buzz Lightyear, and really compelling and enthralling stories like Star Wars and Avengers. And I had absolutely no idea the amount of time or effort it would take to get legal permission to actually include any of those characters or images in this talk. I'm actually pretty jealous of Vanessa right now because she used some Star Wars images. So unfortunately, we're not going to have the opportunity to have any of my slides punctuated by iconic movie scenes or anything like that. So I kind of took the opportunity to explore a new passion of graphic design. It's not going anywhere. You're going to figure that out pretty quickly. So targeting from the perspective of QTE is really focused on how we connect a user with a distribution channel for the media that they want to see. To simplify this, it really means a user comes and says they want to watch a particular piece of media, and we find a URL where they can download that media from. On the surface, this seems extremely simple. Basically, we have all our media sitting on our origin servers. We can contract with one of the outstanding third-party CDN vendors. They can provide that high-quality global distribution network. If we're concerned about the load on the origin, maybe throw an origin shield in place there just to protect against any unexpected load. At that point, user requests a video. We can just mint them a new URL pointing at that endpoint. In practice, though, it's not quite that simple. Disney Streaming delivers video to millions of users across all of our brands. So that includes Hulu, Disney+, ESPN+, and Star+. And it's a global distribution. So we have people all across the world viewing our things. As a result, we have many options on how we can actually deliver that media. And the decisions we make around those particular options make a pretty big difference. So the challenges are really multifaceted. First of all, we have different users in different locations and who have different needs. So for example, we may have someone in Chicago. I told you. We may have a user in Chicago who's watching a video on their laptop in bed on a normal standard network connection, nothing too fancy. They want a reasonable quality. They are used to getting certain amounts of rebuffering. I'm not saying that's me, but I'm also not saying that's not been me. We also have potentially a user in Brazil whose entire experience is on mobile. They expect that they're going to get a lower quality bit rate than somebody who's on a hardwired connection on a major device, but they want to make sure that their playback doesn't stop. They don't get any stutter. They don't get any rebuffering. And then finally, we have the power users. These are people who have, 8K televisions mounted in their living rooms or whatever people have, whatever room they keep their major TV in. They have hardwired connections with gigabit speed. They want to make sure that they can always see the media they want. They want it to be pristine, no artifacts, and no rebuffering whatsoever. In addition, I mentioned how we could just reach out to one of the many great providers out there for CDN services. They have different capabilities as well. First of all, different CDNs are able to offer different capacities to individual clients. Some of them just have different capacities. You may have a CDN who can basically support any traffic you want, where you may have another one that has a limit on the total amount that you can share with them. They have different peering configurations with local ISPs and various ASNs. They also have various physical locations. That includes both the POPs, points of presence themselves, as well as where they do business. We have CDNs that may not actually serve other continents such as the South America or Asia. And then, of course, the little thing that we always try to kind of not talk about, but contracts. Like none of this serving is free. We have to always be cognizant of how we can optimize our spending in order to deliver this quality experience to the user. So we have all these constraints in terms of all of our distribution networks, and our goal is how can we combine all of these to get the best optimal solution both for the customers as well as for our business. Our solution is not that different than what I imagine most people have done. We've created a multi-CDN distribution mesh. So really that's just a fancy word for saying we put a lot of things in a lot of different places. We have globally distributed origins spread, like I say, throughout the world. We also have origin shields, which are maintained internally, which are also distributed throughout the world. And we partner with several different CDN partners, both the traditional commercial CDNs, as well as open cache hosts, and a certain degree of internal distribution mechanism ourselves. So this provides a ton of different options of how we can move our data, our video streams from our distribution context into the actual users. So how do we develop a custom delivery experience for each individual user? In other words, how do we tie that one person to the actual location where they're going to download their stream? It's actually pretty simple. We have experts in our operations team who spend time analyzing and studying the best, what user characteristics look like. So who a person is, where they're coming from, what they're watching, things like that, and can tie those to sets of CDN distributions and endpoint distributions that are going to perform well for them. They encode those as a collection of rule sets, where basically they'll say, this defines a particular class of user, class of viewer, and here are the sets of endpoints that we know are going to work well for them. Within that context, they then assign essentially a static distribution of how much traffic for that particular rule set will be routed to each endpoint. So they'll say, oh, 10% goes to this endpoint and 20% goes to this endpoint. And then when a user comes in, we evaluate the request. We say, who are you, where are you, what are you watching, what time is it, anything else we can possibly come up with, find the rule set that best matches that user, and then assign the final endpoint from that list of endpoints. But this becomes actually really quite hard. We have dozens of rule sets for location, for ASN, for particular media, for experimentations that we run. We also have constantly changing traffic patterns, which shouldn't come as a surprise, and that includes spikes during premiere content release or during live events. And back to that kind of elephant in the room, we have contractual obligations. We can't just send as much traffic as we want to any CDN. We'll have problems. They'll have problems. Pricing differences, other constraints that come from our providers. So traffic is constantly shifting. Again, this is not a surprise to anyone. But our traffic is has a fairly seasonal pattern across months, across days, across hours even. The challenge with this is that if we use those static distributions that I talked about, saying, oh, we want to send 20% of our traffic here and then 10% of our traffic here, the CDN traffic is going to follow those patterns. So it's always going to dip during the troughs and peak during the spikes, which is fine unless you have particular motivations for keeping traffic at a constant rate all the time. Some CDNs do better with keeping caches warm. Some CDNs prefer to have everything loaded into their cache and constantly being hit. We also have some internal tools where we want to keep a constant flow of traffic. So in order to handle this problem, the only real solution would be manual management by operations, and that's what we have done in the past. Basically, those operators that I spoke about would go through and define all of those rules, define those static distributions, and when something would change, they would manually go in and change those distributions by hand. So sometimes that would happen multiple times in a day. So if there was an outage, for example, they would have to go ahead and change all of the distributions to make sure that the traffic was still being routed appropriately. And this could span multiple of those rule sets. It made our general overall allocation planning extremely difficult and tedious because they were constantly trying to calculate how much traffic is going to be shifted around across dozens of different rule sets. On the whole, a significant amount of effort was outlaid just to manage our allocation and distribution planning. So we created Panama. Panama, or ATR, the Adaptive Traffic Routing, is a set of services developed by QTE for use within the Disney streaming products, which is designed to automatically and dynamically route users to endpoints which host our media streams. By using the intelligent routing, we hope to provide both a better experience for our customers and a lower cost for Disney. Primarily, it still takes into account all of the information that we've used in the past for optimizing performance. But by constantly shifting those distribution rates, we're able to lower our overall CDN costs. In addition, it stabilizes and manages traffic value, the volumes to various CDNs and origins as it's able to adjust traffic as the distribution as traffic flows through the system. And it gives a new degree of fine-grained control for some of our internal distribution platforms. So whenever you're thinking about a system, the first thing to look at are the inputs. So for us, we have three major sets of inputs. The first is the usage, how much traffic is flowing through our system. We need to divide that up by all of our different dimensions. Secondly, those operator preferences. For us, this is primarily focused on their experience and understanding around how to target users for quality of experience. But it also can be used for our overall traffic allocation. And then finally, the new piece that's really been brought in for Panama is these sets of higher level constraints that are applied to various endpoints. So we can specify what the minimum amount of traffic that an endpoint should get at any given time, the maximum amount of bandwidth that a endpoint should get at any time, and then a couple of controls around the acceleration or the way traffic is added to or removed from endpoints. So the data flow is as such. At first, the first step is always to calculate how much traffic we saw previous. So we do this by using a number of different data sets, including client telemetry, including usage logs that come from the CDN providers and other tools to come up with a clear and precise estimate of how much traffic was actually used during the past minute. We then slice and dice that across all of our dimensions. So that includes the applicable rule sets, it includes the ASN or the ISP, and a few other dimensions that we work with. So that, at this point, we have a clear picture of exactly how much traffic was passed through all of our different dimensions for the past minute. The second step is to calculate the desired routing or the ideal routing. Once we have that data, it's really, really easy for us to go back and well, this is how we did distribute the traffic, but how should we have distributed the traffic? And realistically, this can be done with paper and pencil, but once you start to get to scale, that becomes really hard. But basically, we take the data from the previous minute, calculate what we should have done if we had done it correctly, and then that's our ideal distribution. Next, we adjust our distribution from what we actually did towards what the ideal was. I use that word towards very deliberately, and I'll come back to that in a second. And then finally, we actually route the traffic. So for the next minute, we have our new sets of distributions where we are receiving requests and making the decision to allocate traffic based on those distributions that we had come up with and passed on to the next step. And then, of course, we repeat. Like I say, this happens every minute. We're recalculating our distributions on a minute-by-minute basis to account for the actual usage in the system. So this is essentially what we use to calculate what the ideal distribution is. And like I said, you can do this with pen and paper. I'm not going to make you do it with pen and paper, but you can. You start with that usage data that we've observed and calculated, and then that set of operator preferences. We now know that we have all of these different rule sets, and we need to allocate how much traffic in the previous minute was that particular rule set responsible for. That way we can divide up all of the distributions across the entire system. So once we've done that, we now know how much of the minimum each individual rule set was responsible for. So we go through and we say, step one, assign the minimum amount of traffic to all of the different rule sets for all of the different endpoints. So at this point, we now have, in theory at least, in an ideal situation, we would have allocated the minimum for sure. We then have those operator preferences where we talked about how the operators have the expertise to help guide us in how we allocate the additional traffic. So we allocate the rest of the traffic based on those proportions. Again, per rule set, we say, okay, well, this one's going to get 25%, this one's going to get 50%. The challenge here, of course, not really challenge, but the issue here is that you can run over your max. So if you hit over your max, you cap it at the max and then distribute it amongst the rest of the properties, again, based on the preferences that have been supplied by the operator. Really, really simple. Definitely can do it in your head. Becomes a lot more complicated when you have to do it across 90 or 100 different rule sets. Okay, this is the next piece and sort of the why I said we're moving towards the ideal. If we were to say, well, in our last time step, we did this, and we know that we want to get this much traffic, the first thought would be, well, let's just move that traffic and say, well, we're going to shift, instead of using this set of distributions, we're going to use this set of distributions. But the challenge is that because the traffic is constantly moving, if you're on an uptick, you have a high chance of over-allocating to any individual CDN because you're looking at what happened in the past minute as opposed to what's happening in the next minute. And if you're in a spike type situation, like for a new content release, you can really run into problems because you've suddenly allocated way more traffic than a particular endpoint can handle. So to address this, we introduced a controller, basically a PID controller. You can think of it as like cruise control for your CDN distributions. What this does is take, in addition to looking at what the ideal would have been, it also takes a historical view of how wrong we've been in the past. Like, were we really off? Do we really need to speed up to try to catch up to our ideals? Or was this sort of a one-time anomaly that we should sort of smooth out? And that's really what this approach does. It smooths out our traffic shifts so that we're not jumping up and down and all over the place and more moving towards our ideal and able to handle perturbations in the system. So it really is like a cruise control. You know, if you hit a hill, all of a sudden your system is going to kind of back off, but it's not going to like slam on the brakes. It backs off until it finds, and so you may end up going over the speed limit, which I can't help you with that. But eventually it's going to find its equilibrium. This is the other one that I wanted to point out, my drawing here. The original was great, just for the record. We provide an additional layer of control to give more fine-tuned capabilities to the operators in the form of acceleration constraints. So we've got this smoothing mechanism from the PID controller, which allows us to make sure that we're not jumping too far too fast. But it's still possible that if there was a huge jump in traffic, we could try to allocate a significant amount at once. By adding these acceleration constraints, we essentially say, this is how much traffic you can add to a particular endpoint minute over minute. So it'll be in the form of something like 50 gigapips per minute. Okay, that's how much traffic we can have. So that will force, even if we want to go really, really far and really shoot up to the top, it'll force us to take a more measured approach and protect both the CD and the edge from getting saturated too quickly. We also have another, this actually happens before the controller is applied. So basically it says, we use this acceleration constraint to restrict what the ideal distribution would look like. We also have a second sort of ripcord, which is the request increase, which happens at the very end. It says this endpoint cannot receive more than 3% more requests minute over minute because we're afraid that it'll explode. So between the two, we have a strong throttle that we can apply to the system. We have the controller, which applies sort of the smoothing technique, and these additional constraints, which act basically as a throttle. So the workflow is pretty simple. I'm actually not going to go through the workflow in too detail because I know everybody wants to go to lunch. But basically, we take the distributions that are generated every minute. We use them in coordination with some of the data created by other parts of our system. We allocate based on those new distributions, determine if tokenization is required, and then generate the URL. So the question is, how do we measure success? Well, I already mentioned peak to average, the idea that there are some CDNs that we really want to keep at a fairly level peak, making sure that we stay within our bounds, volume targets, trying to hit our distributions at the end of the month, and smoothing out those spikes. So this was the slide from the beginning. After we applied Panama, this is what the actual distribution looked like. So the one that's in blue is a CDN that we were particularly focused on keeping very flat. You can see there's sort of a sinusoidal pattern there, and that's just sort of is the nature of using this kind of control mechanism, that it's going to be hovering around sort of what its equilibrium is as it's adjusting. We've actually adjusted since then. We've adjusted some of the parameters, and it's smoothed out even more. But this is what we would consider to be a successful deployment for a CDN where we want to keep a steady level of traffic all day, no matter how much is being applied to the overall system. But while Panama is responsible for determining those session distributions, it's not the entire story. We also have, and no time to go into some of these, and I'm hoping that some of my colleagues will come and give talks on some of these in the future. We have a model-based session quality of experience service, which generates how well we think a particular service is going to, a particular user is going to perform on an endpoint, which sort of does similar to what the operators do. We have an allocation system, which takes the distributions that we've generated and those quality of experience rules and merges them together. Support for failover, both in terms of video start failure as well as video playback failure. We have a circuit breaking mechanism for catching acute issues before they cause problems. We have a slow endpoint introduction system for when you want to bring a new endpoint into the overall system and you don't have any historical data for it. And then we have tools for doing volumetric targeting allocation. So, wow, I hit it right on the dot. Thank you very much. That is Panama.